So this is section 10.3, proofs with parallel lines, very similar to what we covered in 10.2. I'll explain the differences when we get there. So we're going to use the corresponding angles converse and prove a theorem about parallel lines and use the transitive property of parallel lines. So in section 10.2, you were given a transversal intersected by two parallel lines. And you saw that different angle relationships, angle pairs were congruent or supplementary, but you were given a transversal intersecting two parallel lines. Therefore, angles were congruent, like alternate exterior, alternate interior, and corresponding angles, while consecutive interior angles were supplementary. In 10.3, it's going to be the other way around. So here you're going to be given angles being congruent or supplementary, and thus you can conclude lines are parallel. So we start with the corresponding angles converse. Remember, converse is the opposite of the definition. If two lines are cut by a transversal, so corresponding angles are congruent, then the lines are parallel. In other words, if angles 2 and 6 are congruent, then J is parallel to K. So here you are given the angles being congruent. If they're congruent, then you can conclude the lines are parallel. So notice how it's different than 10.2. 10.2, you are given parallel lines, therefore angles are congruent. Here you're given angles congruent. If corresponding angles congruent, therefore lines are parallel. J is parallel to K. We also have rules for the other three angle relationships that we saw in 10.2. Alternate interior angles converse says if two lines are cut by a transversal so that alternate interior angles are congruent, here 4 and 5, then the lines are parallel. So if angles 4 and 5 are congruent, lines J and K are parallel. Same with alternate exterior angles. If a transversal cuts two lines and the alternate exterior angles are congruent, here 1 and 8, then lines J and K are parallel. So again, you were given angles congruent, therefore the transversal intersects two parallel lines. Finally, the consecutive interior angles converse. Here, if two lines are cut by a transversal, so consecutive interior angles are supplementary. So angle 3 plus 5 is equal to 180. Then the lines are parallel. So the way you would solve most of these problems is very similar to what we did in 10.2. In 10.2, you were given parallel lines. Here, you're going to be asked a series of questions such that find the value of x that makes m parallel to n. So 1a, find the value of x that makes m parallel to n. So for m to be parallel to n, you need these two angles, 3x plus 5 and 65, to be congruent. What kind of angles are they? They are corresponding angles. So for the lines to be parallel, the corresponding angles have to be congruent. So you're going to set the 3x plus 5 to equal 65 and solve for x. Subtract 5 from both sides, divide by 3, and you see that x is equal to 20. 1b, find the value of x that makes m parallel to n. So now we have other angle pairs. We have a 72 and a 4 times the quantity x plus 5. Now notice these are not any particular angle relationship. They're not alternate exterior angles because they're not on opposite sides. It's transversal. But you can still use the corresponding angles theorem, because if this angle up here is 72, since it's a linear pair with the angle right below it, which is this one, that angle has to be 108 degrees. 72 plus 108 has to equal 180, which means 4x plus 5 is corresponding angles with 108. For the lines to be parallel, 4x plus 5, 4 times the quantity, x plus 5 has to equal 108. So we solve for x, distribute the 4, so we get 4x plus 20 equals 108. Subtract 20 from both sides, you get 4x equals 88. Divide both sides by 4, you get x equals 22. Go ahead and try examples 1c and d. You can pause the video and then resume it when you're ready to continue. 1c, 180 minus x and x. Find the value of x that makes m parallel to n. What kind of angles are these? You'll have to know these are alternate exterior angles. So for the lines to be parallel, the 180 minus x angle has to equal the x angle. So we set them equal to each other. X equals 180 minus x. We're going to add x to both sides to isolate the x. So 2x equals 180. Divide both sides by x out by 2. And so you see that each angle is actually 90 degrees. 1d, again, find the value of x such that m is parallel to n. So you need these two angles to be in a relationship with each other. What is that relationship? What kind of angles are they? They are consecutive interior angles. So consecutive interior angles have to be supplementary for m to be parallel to n. So we're going to make them equal to 180 when you add them up. So 6x plus the quantity 2x plus 20 has to equal 180. Combine like terms, you get 8x plus 20 equals 180. Subtract 20 from both sides and divide by 8. And again, you see that x is equal to 20. So for these problems, very similar to 10.2. In 10.2, you had to find the value of x such that the angles were congruent or supplementary, given that the lines are parallel. In 10.2, you were given the lines, you're given the angles are congruent or supplementary. You had to find the value of x to show the lines are parallel, but the way you solve them is exactly the same way. So in example 2, we're going to prove the alternate interior angles converse. Given angles 4 and 5 are congruent, we are going to prove that G is parallel to H. So we'll start with statement 1. Angle 4 is congruent to angle 5. That is given. Number 2, angle 1 is congruent to angle 4. How do you know angles 1 and 4 are congruent? What is it about these angles that are the same? And they are vertical angles. So reason 2, vertical angles are congruent. That's the vertical angle congruence theorem. So since angles 1 and 5 are both congruent to angle 4, they have to be congruent to each other. Why? That's the transitive property of congruence. Two angles congruent to the same angle have to be congruent to each other. Statement 4, G is parallel to H. Why is that true? That's the corresponding angles converse. That was the first rule we looked at. So since angles 1 and 5 are corresponding angles and they're congruent, that means G has to be parallel to H by the corresponding angles converse. So this is the proof for the alternate interior angles converse. The final topic for 10.3 is the transitive property of parallel lines. And it works like the transitive property of equality and congruence. If two lines are parallel to the same line, then they are parallel to each other. So if P and Q are parallel, and Q and R are parallel, then P and R have to be parallel to each other. So two lines parallel to the same line have to be parallel to each other. So P is parallel to Q and Q is parallel to R, then P has to be also parallel to R. That's a transitive property of parallel lines. Final example 4. The flag of the USA has 13 alternating red and white stripes. Each stripe is parallel to the stripe immediately below it. Explain why the top stripe is parallel to the bottom stripe. So this is basically the transitive property of parallel lines on steroids. So we know each line is parallel to the one right below it. So we know S1 is parallel to S2, S2 is parallel to S3, and so on all the way down. S3 to S4, S4 to S5, all the way down to S11 parallel to S12, and S12 parallel to S13. You can do a mega transitive property because S1 is parallel to S2, S2 is parallel to S3, therefore S1 is parallel to S3. You can basically make that all the way down. So since all the lines are parallel to each other, S1 has to also be parallel to S13. Most problems dealing with parallel lines, transitive property won't be anything that's complicated. It'll basically be two lines parallel to the same line have to be parallel to each other. That's it for section 10.3. If you have any questions, ask me on Google Classroom or send me an email. And don't forget to do the homework assignment. It matters.